Alright, this LeetCode question is called climbing stairs. It says you are climbing a staircase. It takes n steps to reach to the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? And the note is that given n will be a positive integer. So the first example, the input is 2, so 2 steps, and the result is 2 because there are 2 ways to climb to the top. You either take 1 step and then 1 more step, or you just take 2 steps at once. And the second example, the input is 3, so 3 steps, and the result is 3 because there are 3 ways to climb to the top of this. Either you take 1 step, then 1 step, then 1 step, or you take 1 step and the 2 remaining steps at once, or you begin by taking 2 steps at once and then take the remaining 1 step. Alright, so first things first. Let's say you're at the bottom of the staircase and you only have 1 step left to go. If you take 1 step, you're at the top. You're good. So that's a valid path. But if you try to take 2 steps, you fall off the edge and you're done. So that is not a valid path. Next thing to note, although it sounds trivial, is how do we know that it's a valid path? We know it's a valid path because there are 0 steps remaining. Right now we're at the top. What's not a valid path is if you exceed the number of steps remaining. So if you take a step and then you take 1 step too many, now how many steps do you have remaining? You have -1 steps, and that won't work. You need to have exactly 0 steps remaining for it to be valid. Alright, so the question says that we can either take 1 step at a time or 2 steps at a time. So let's pretend that the question asks us how many paths are valid if there are 3 steps total. What we can do is think about it like this. If there are 3 steps total, we can either take 1 step or we can take 2 steps. If we take 1 step, how many steps are remaining? There are going to be 2 steps remaining. Now, if there are 2 steps remaining, how many possibilities are there? We can again take 1 step or 2 steps. If we take 1 step, how many steps will be remaining? There will be 1 step remaining. Now, if we have 1 step remaining and the possibilities are either we take 1 step or we take 2 steps, here's how that would look. If we take 1 step and there's 1 step remaining, we're good. We're at the top of the staircase. That is a valid path. But if we have 1 step remaining and we take 2 steps, we fall off the edge. That will leave us with -1 steps. That is not a valid path. But remember how we even got to those steps. We had 3 steps. We decided to take 1 step, putting us here with 2 steps remaining. And then we took the path of taking 1 step from there. But what if we go the other route and take 2 steps? Then what does it look like? If we have 2 steps remaining and we take 2 steps, that is a valid path because we have 0 steps remaining. Let's spread this out to give us more space. Okay, the results we just saw are if we have 3 steps remaining and we go down the path where the first thing we do is take 1 step. But what happens if we go down the other path, the path to the right, where we have 3 steps remaining, but the first thing we do is take 2 steps? That'll put us right here. Now what options do we have? We have 3 steps remaining and we take 2 steps, so now we have 1 step remaining. With 1 step remaining, we'll do the same thing. We always can either take one step or two steps. If we take one step, guess what? Now we have 0 steps remaining, and we're good. That would put us at the top of the staircase. But if we have 1 step remaining and we take 2 steps, now we've exceeded the number of steps that there are, so that is not a valid case. So now all we have left to do is count the number of cases where the steps remaining equaled 0, because those are the only valid paths. So we have 1, we have 2, and we have 3. This is why when you have an input of 3 steps, the output is 3. Let's clean this up a bit. Remember that the initial number they give us, the number of stairs remaining, is n. So n equals 3. Every case we've described is either an n-1 case or an n-2 case. So if you look to the left, that's what happens when n equals 3, and we start out by only taking 1 step at first. So that would be n-1. If you look to the right, n is 3, and we take 2 steps, so we'd subtract 2 from n, which would give us n-2. So the n-1 case for our original number gives us 2. The n-2 case for our original number gives us 1. 2 plus 1 gives us our final answer of 3 different valid paths. But that's not all. If we go one level deeper, we'll see the number 2 on the left side. So that's what would happen if n was equal to 2. So even for the number 2, we have an n-1 case and an n-2 case. And then we go one level deeper than that, we have the number 1. So for the number 1, we have an n-1 case and an n-2 case. If n is 1, you only have one valid path. If n is 2, you have 2 valid paths. If n is 3, again, we have these 3 valid paths. If you look to the right, we have the case where n equals 1 again. So for n equals 1, we also have an n-1 case and an n-2 case. But if we remember, we already calculated n-1 over here. We already know that if n is 1, we only have one valid path. But we've calculated it twice, and of course seen the same result. Calculating the same thing twice is expensive. What we should do is anytime we get to the result of one of our paths, we should save that somewhere. So let me clean this up. Let's create a map for all of our results. And let's start at the bottom here. We know that when n equals 1, we only have one valid path. So when n is 1, we'll give it a result of 1. What else do we know? We know that when n is 2, we have 2 valid paths. 1, 2. So when n is 2, the result is 2. So now we're trying to calculate the results on the right side, and we get to the number 1. Instead of calculating the valid paths, we should just be able to look in the map to get the result. And finally, now that we know how many valid paths there are when n is 3, we can also add that to the map. So any time we solve for an n, we just add it to the map, because even though the top level n is 3 in this case, what if it were 10? When you're calculating n being 10, you're probably going to stumble upon the case where you have 3 steps remaining multiple times. This process of storing our results so that we don't have to calculate them more than once is called memoization. No, I'm not misspelling it. It's not memorization. It actually is memoization. All right, let's start with what LeetCode has given us. It's a function called climb stairs that accepts n, and n is the number of stairs remaining. Like I mentioned before, I'm going to solve this one recursively. In order to do this, I'm going to create an inner function to help us out. So I'll say let counting func, short for function, equals a function. And what does it accept? It accepts stairs remaining and something we'll call save results. Stairs remaining is the number of stairs remaining in that recursive call, and saved results is going to be the map that holds all of our saved results for valid paths. All right, so let's start off this function by calling it with n, and this is where we'll create our saved results map. So right now, all we're doing is we're calling the counting function we just created, and we're going to pass in the original stairs remaining, which is n, and we're also passing in a map, which is going to hold all of our valid paths. Okay, so let's get a couple base cases out of the way. We know that if stairs remaining is a negative, it means that's not a valid case. In that scenario, we'll just return 0 so that that case doesn't increment our valid results count. So if stairs remaining is less than 0, we'll just return 0. On the flip side, we also need the case where stairs remaining is 0. And remember that if stairs remaining ever equals 0, that is a valid case, so we need to return the number 1. So anytime this happens, our valid results will increase by 1. And remember how we talked about memoization earlier, which is just saving the results so we don't have to compute something multiple times? We also need the case where if we've already calculated the results of the number we're on, we can just return that result instead of doing the calculation over again. So if, remember the map that we created is called saved results. So if the number of stairs remaining in whichever iteration we're on is already saved in our map, we can just return that number. So saved results. But if we get past all of those if statements, it means we haven't seen this number before. So in that case, we have to calculate the result for whatever number we're on and save it to our saved results map. This is the part of the method that does all of the recursive calls. If you're not familiar with recursion, it might seem a little mind-bending, but once you get used to it, this part would make sense. I'll still try to walk us through it step by step. But first, let me just type out the whole line. So remember, we're saving whatever result we're on to the map. So saved results for whatever stairs are remaining equals. We're going to call our inner function, which is called counting func. And we're going to call it with our two scenarios. So stairs remaining minus 1 plus the other scenario, which is when we subtract 2 from stairs remaining. And don't forget, we have to pass in our saved results map every time. So we can get the current value of the saved results map. Okay, so if we look to the drawing to the left, remember these are our two scenarios at first. Let's say n equals 3. The path on the left is when you subtract 1 from n, and the path on the right is when you subtract 2 from n. Remember our tree when we filled it out, at the very end we counted up the number of successful paths in the left side, which is the n-1 side, and the number of successful paths in the right side, which is the n-2 side. Which is why, if you go back to the code on the right, we're adding counting func stairs -1 plus counting func stairs -2. Let me clean some of that up. And since this is a recursive call, at the very end, now that we have the result of that saved to our saved results map, we have to return the results of whatever we just calculated for whichever number of stairs we're on. All right, so I'm sure that's super confusing, but I'll walk through that. Let me get rid of this and then rid of that. Okay, let's start with the first iteration. On the first iteration, if you go to line 25, we're going to pass in the number of stairs remaining, which is n, and our saved results map, which right now is an empty object. Now it goes to the if statement on line 8. It's asking if stairs remaining is less than 0. In this case, it's not, because stairs remaining is 3, so it goes to the if statement on line 12. This time it's asking if stairs remaining equals 0. And again, it's not, because stairs remaining is 3. Line 16, have we ever seen this number of stairs before? We haven't, because our saved results map is empty. So now it'll get to the recursion on line 20. It's going to go into those two functions, and then once it has the results of those functions, it's going to return into the saved results map where the result is going to be saved. So let's show you what the recursion is. So the first one is, again, line 20, counting func stairs remaining -1. Stairs remaining right now is 3, so what's going to be passed in is 3 minus 1. So for right now, we'll ignore the second half of that, the part that says stairs remaining -2. So we're on stairs remaining -1. 3 minus 1 is 2, so that's here. So now what happens is that it goes into line 8, and this time stairs remaining is 2. Is 2 less than 0? No. Let's go to line 12. Does 2 equal 0? No. Have we ever saved this number of stairs in the map before? No. So now we go to line 20. In the first part of line 20, we need to call counting func with our current stairs remaining, which is 2, minus 1, because this is the path where we're just taking one step at a time. What's 2 minus 1? 1. That'll look like this. All right, so now we're back to line 8, but now stairs remaining is 1. Is 1 less than 0? No. Line 12. Does 1 equal 0? No. Line 16. Have we ever seen this number of stairs before? No. So we go to line 20. We're going to call it with stairs remaining, which is 1, minus 1. So now our stairs remaining equals 0, and that's what we'll take into line 8. Does our stairs remaining, which is 0, is it less than 0? No. We go to line 12. Does our stairs remaining equal 0? Yes, it does. So this is what our path looks like at this point. That is our first valid path. So now it jumps back out of that iteration and makes our stairs remaining 1 again. Remember, there's another path it now has to take. The path where we try to take 2 steps. What's 1 minus 2? It's -1. So that is not a valid path. So now it jumps back out another level to where the stairs remaining equal to 2. So now what it does is it takes us into counting func with stairs remaining, which is 2, minus 2. So we go into counting func. Line 8, is 0 less than 0? No. Line 12 though, remember we passed in 2 minus 2, which is 0. Does 0 equal 0? Yes. So for this path, it is successful. And now we've gone over all the scenarios for our first path, which was when our first step was to subtract n minus 1. And at this point, our map has those 2 successful paths. So the first one we found was by going down the path for 1, and then after we went down the path for 2, we added 1 more to the successful paths. All right, so now we're all the way back to the very beginning where n was 3. And the first path we took, I'll say it again, is the stairs remaining minus 1 path. But now we have to fill out the stairs remaining minus 2 path. So again, stairs remaining is 3. What's 3 minus 2? That's 1. That'll put us here. So now we'll take that into the counting func function, which would put us at line 8. Our stairs remaining right now is 1. Is that less than 0? No. Line 12. Is 1 equal to 0? No. But now we're at line 16. It's checking whether the number we're on, which is the number 1, is in our map. It is in our map. So what this iteration will return is the value, which is the number 1. So now let's take a step back to quickly summarize what we've done. We created an inner function that passed in the original stairs remaining and a new map containing all of our valid results. We started with the number 3, and we've gotten the results for when you pass 3 into counting func when you start off by subtracting 1, which is this end. It gave us 2 successful results. And when you passed 3 into the other half of the counting func when you started off by taking 2 steps at once, that gave us 1. So if you look at what line 20 is now, it's saying to save the result of our left half of our tree, which is 2, plus the right half of our tree, which is 3. So it saves it into our map and then returns this value, which is the number 3. All right, I know that was super confusing, but when you have time, just go over recursion a little more. After it clicks in, it'll be a lot less complex. Anyway, so let's see how we did. Let's run the code. Looks good. Let's submit it. All right, so our answer was faster than about 42% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. See you next time.